My name is Roslyn Bacha, and my spatial analysis project is on water nitrate concentration and cancer incidences in Wisconsin. High nitrate concentration in drinking water are a health hazard and recently possible risk of cancer. So, charged by the Wisconsin Department of Natural Resources to search for a possible relationship between nitrate levels and cancer occurrences, I made use of data files such as the county shapefiles, test wells shapefiles, nitrate data, and cancer-related incident reports. To determine the relationship between nitrate and cancer, Python scripts were developed and run in an ArcMap exclusive environment. These scripts were developed and written to be able to run spatial analysis such as the inverse distance weighting and the ordinary regression analysis. These scripts now were combined to form standalone scripts and also added functions to be able to create a graphic user interface to aid the user run these different spatial analyses and be able to input different K-power values, view and download project files. So demonstrating how my application works, I have to open the ArcMap environment and I click open the Python shell where I copy my Python scripts that were written in the with the aid of brackets. I now paste the script within the Python environment and I execute the script. It's going to take some time to execute the different functions. We can find below the this area that the script is succeeding in its execution. We can find the shapefile of the Wisconsin state. We can also find that some statistic tables are being generated, and we can also find that we have output of the IDW, and we also have output of the OS results. We can find the R2 adjusted result statistics that are very crucial to explaining the relationship between nitrate and cancer occurrences. So now to generate our graphic user interface, we copy the scripts from brackets, we paste it onto the Python shell window, we execute and we give it some time to run. And now the simple application has been generated. We find it has a simple interface, very easy to navigate. We have the about frame section that gives you an overview of what this application is and what it can attain. We have below that, we have a small frame that gives us the possibility of inputting different power K values. For example, let's say we input the power 2 and we run it. We'll find the analysis being generated. We find the flashes and different shape output results being overwritten and displayed within the ArcMap environment. We can find that it has succeeded. And we have one slight error coming up. We find zonal statistics table not being able to be executed. So with this application, you can also be able to view results that were run in the back end. For example, when we click the inverse distance weighting, it gives us that output. We can find the county shapefile overlaid on the output results, and we can find different areas of concentrations. When we click on regression, I was not able to generate that output. I don't know what the problem is, but I'm working on debugging that. And below that frame, we find view files where we can migrate to the different project files. If we click here, it takes us to the different areas to migrate, like quick access. It can take us to, for example, this is my project files. You find the different files within that are used in the project, the different shape files and resulting files. If you click on the project demo, it's going to launch you to CMD, and then gives you the project. It has been noticed that can walk you through that high nitrate concentrations in drinking water. So we close this so we can move on to. And recently, possible risks of cancers in adults. So this is our application. It's very simple and easy to navigate, and it gives the user the possibility of running this different spatial analysis, input different K power values, view project files, be able to have a project demo that walks you through how this application is supposed to be used and what this project is all about. So this is our simple application, and I believe that this application will be able to help. I believe this application will ease the load of users who want to run this type of spatial analysis. So interpreting the regression analysis results, the analysis results tell us that there's a relationship between nitrate concentration and cancer occurrences in Wisconsin. When we look at this output from the ordinary least square regressions analysis, we can find areas in red that tell us that the dependent variable was over modeled in these areas, and the areas in blue, they were least modeled. And when we look at the adjusted R value, that is 0.33, we can confidently say that the R value gives us a 33% levels of prediction that nitrate water results in cancer occurrences. So with a 33% levels of prediction of cancer occurrences by nitrate concentrations in water in the state of Wisconsin, one can safely conclude that water nitrate concentrations are a cause to cancer occurrences within that state. But then again, it is what creating a hypothesis that these predictions are not good enough, they are not very good enough to conclude that they are the sole cause of cancer occurrences within the state of Wisconsin. So it would be good to further carry out analysis using different causal variables such that we can have a comparative analysis of the AIC values and P values, which are also subjected and used in determining the growing concern of occurrence of cancer within the state of Wisconsin. So conclusively, this project can conclude with the 33% levels of significance that nitrate concentrations at test well locations tell that they are a big contribution to cancer occurrences within the state of Wisconsin. Thank you.